Right. This section is, I say it about every section, but it is one of the most important sections. Now, I'm saying this not only because it is part of your matric paper, but it's actually part of your matric paper as it is. Like, what I mean is they can actually ask you your limiting reagent in the matric paper. So it's not like other sections where I've told you it's in your matric paper, but it's part of another section, or it leads you to a section from your in your matric paper. This can actually be asked, and I can give you a lot of past papers for you to do once you're okay with this. Now, this can be tricky to understand, so I'm going to try my very best to explain this to you in a way that will hopefully will help you remember. Remember, I don't like you to learn things off by heart. I like you to understand things. So it's called limiting reagent or reactants. A reagent and a reactant are the same thing. I think Americans often call reagent, but it's the same thing. When will you be asked to do it? Well, obviously, when you asked for it, they can literally say which one's the limiting reagent, okay? Or if you haven't been asked for it, but you have been given two pieces of information or information for two reactants, and you'll see when I start doing the equations what I mean by this. So I have an analogy for you, okay? So if we take pieces of bread and we put cheese between them, we're effectively making a sandwich, right? So I've actually got props. So here are my pieces of bread. Don't judge, I know it's bright orange bread, but anyway, it's a visual. Okay, oh, I've already lost one of my pieces of bread. Seriously? Okay, that's fine. I'll just cut down on my cheese then. Okay, so if I have, I've got 6 pieces of bread here. Okay, 6 slices of bread. Okay, you can see them all. And now I know, hey, look at my cheese. I even made an effort for you. And now I have 2 pieces of cheese. Okay, so I want to make sandwiches. So what we do, they are going to react. So I take 2, and there I have 1 piece of bread. There I'm putting my cheese on top, and I make a sandwich. Here's my other one. Tristan, am I making you hungry? And I put another piece of there. Oh, how cute. Look at my sandwiches. And there are my 2 sandwiches. Okay. Now, if we have a look, we've still got 2 pieces of bread left over. So in this case, you can see one of these, bread or cheese, limited the amount of sandwiches we could make. Okay, so gosh, okay, so it actually, so cheese limited, all my cheese is gone. Okay, it limited the amount of sandwiches we could make, whereas bread, we can say, was in excess. Okay, there was too much and there will be some left over. So one of them will react completely and the other would be in excess. The one that reacts completely will be the limiting reagent. Okay, so I'm going to now show you again how we're going to do this, how are we going to work this out. So I'm going to use the analogy to carry on the calculations, because this is where it starts getting a bit tricky and a lot of people battle with this. Okay, so what we're going to do is I'm going to keep up with this analogy. So the first step I'm going to do is you must realize that we're going to use the information that's been given for both of our pieces. Oh, let's just take a look quickly. Can we balance this? Okay, well, we know that our sandwich is actually made up of bread, 2 slices, and cheese, 1 slice. So if this was a chemical equation, it would be bread to cheese. Okay, so that means that we have 2 slices of bread for every 1 piece of cheese. So there's our ratio that we always work with. Okay, so let's take a look at this. So the first thing I want you to write is, well, how much do you have? How much of each? Okay, now this is important. You use both sets of information. Okay, so how much? So in this case, I have 6 slices. Okay, here we have 2 slices. Okay, the next thing we're going to go, okay, well, from that information, how many sandwiches can we make? Or let's just go, can make. Okay, we can make 4 sandwiches. And here we can make 2 sandwiches. We are still treating them as separate. Okay, I'm looking at that information. 6 slices could make 4 sandwiches. Oh no, sorry, I'm busy copying because I've lost 2. Oh no, you're gonna moan at me. All right, 3. I'm looking at the notes that I made earlier, and then I lost a piece of bread somewhere along the way. Okay, so sorry. Okay, so we started with 6 pieces. 6 slices of bread is what we've been given. We can make 3 sandwiches with 6 slices. 2 slices of cheese, and we can make 2 sandwiches because they each have 1 slice. Okay, so we have worked with both of them. Now comes the comparison. You need to compare. Now, we can compare bread to cheese or cheese to bread. It doesn't matter which one you are going to use. Okay. So the first one we're going to do is we're first going to say, okay, well, we know that 6 slices, okay, of bread needs, that's very important there, needs how many pieces of cheese? Now is when we use our ratio. We know it's 2 to 1. Okay, divide by the first times by the second. Okay, so that means that this becomes, divide by the first is 3 times by 1 is 3. So that means needs 3 pieces. Oh gosh, sorry, pieces of cheese. Notice that I've just taken this one thread from bread. I'm now moving it over to the cheese side, but I'm using a comparison with my ratio, and I'm taking bread and I'm comparing it with cheese. Now we take a look. Okay, so 6 slices needs 3 pieces of cheese. How many do I have? We don't have enough. Not enough. Okay, we don't have enough. So whatever one we don't have enough of, we would say, therefore, that is the limiting reagent. So therefore, cheese is limiting. What is the bread then? Bread is excess. Okay. And that's how we're going to do it. I'm going to tell you just now what each of these mean in terms of a equation. So I'm going to show you another one of these where we are going to use the same analogy, but this time I'm going to show you when the cheese is in excess. Okay, so how does this change? Okay, so I can take, there's my bread, and we know it's 2 pieces of bread to make 2 sandwiches. There's my ratio. Notice I haven't done anything with the sandwich yet, okay? Because we first have to decide which one is limiting before we can start working out sandwiches. All right, so in other words, I could say to you, oh no, don't worry, I'll do it later with you. Then rather let's just look at the analogy. Okay, so I've got the same formula, but this time I have less bread. Okay, so what do? The first thing we do is how much do we have? Okay, And now we have of bread, we have 4 slices. Of cheese, we have 3 slices. Okay. How many can we make? Okay, I can make, and obviously you do have to look at your ratio here, because you can see here it's a 2-to-2 ratio here. So you can make, in this case, so we would have 4, oh sorry, no, what did I do here? Oh no, man, sorry, that's a 1. Sorry. Okay, so 4 slices can make 2 sandwiches. Okay, 2 sandwiches. Now this one, 3 slices can make 3 sandwiches. Oops. Okay, now we compare. Now you don't have to compare cheese now to the bread. You can still compare the bread to the cheese, because at this, you know, when you're doing this with chemistry, you're not going to know until you've compared which one is in excess. So you can do the first one to compare. So compare. So I'm going to take this one and I'm going to say, okay, I have 4 slices, okay, and 4 slices of bread needs 2-to-1. How much cheese? It's going to need 2 slices of cheese. Okay, so it's going to need, that needs that much. So now we compare to the amount of cheese we have. Oh my gosh, we've got 3 slices and we only need 2. We've got too much. Okay, and so therefore the cheese is in excess. Sometimes it's easier to actually decide which one's in excess, and the bread is limiting reagent. Okay, so it's important for you to realize that once you have decided which one's the limiting, you are only ever going to use the information about the limiting reagent to work stuff out now using that equation. Okay, so if, for example, now I say to you, well, how many sandwiches did you make? So now you're not going to look at the cheese. We don't have to look at the cheese because we know that's in excess. So what we'll do is we'll look at the bread and we'll say, okay, we've got 4 slices, so we can make 2 sandwiches. That's it. Now you are only comparing bread to that. We actually can ignore this. We know it is in excess and we need to use the bread to calculate how many sandwiches. Okay, I hope that makes sense. Please rewind and carry and watch it again and again and again. Okay, because now I'm going to do the page 5 with you. Now girls, this is very important. I have put this in your summative assessment, so please make sure you know how to do this. Okay, so this just all says exactly what I've been saying. All right, so example 1. In an experiment, now one thing is that even if you're given more grams of iron here than sulfur, you don't always know if that's going to be your in excess and that one's going to be in excess, because remember, each atom has its own molar mass. So a little bit of iron could weigh more than a lot of sulfur. Okay, so you can never look at the masses alone. You have to get to the moles. Okay, so let's take a look and see what we're going to do here. So 20 grams of iron, and we'll react with 14 grams of sulfur. Now this is what I mean by you are given 2 pieces of information of 2 reactants, okay, of 1 each. And now it says calculate which of the 2 substances is in excess. Okay, so we need to just check that this is balanced. I'm happy that it's balanced. Okay, it's 1 to 1 to 1. I thought I'd start you off slow. Okay, now I don't need to look at the product. I'm going to go off screen with the product. We don't need to know about it. We are now going to look at these 2 and compare them. Paired just like we did with the cheese. Right, so the first thing I'm going to do, I'm going to work out my number of moles. So this is how much we have. Okay, well, actually, this was how much? 20. I'm now going to work out moles. So how many? Well, it's kind of like the sandwiches. How many sandwiches can I make? Right, so mass over molar mass. Iron is 56. Okay, and I have 20 divided by 56. And I get 0.36 moles. All right, so this is my number of sandwiches, if I can draw your attention to what we did. So the analogy. So this was the first step, was getting your information. The next step is getting your moles. The next step is to compare. Okay, so moles and compare, but I can't compare until I've done this. So now I'm going to do the same thing to this one. I have to also get the number of moles of this one. Moles is equal to 14 over sulfur is 32. Okay, so 14 divided by 32 gives you 0.44. Okay, now technically you can look at the moles now and just look at them and see which one's more than the other, because they're a 1-to-1 ratio. But I'm going to go through the motions of this so that you understand. So now we compare. And I can take either one of these and compare it to the other one. Okay, you don't have to do both. So I'm going to take this one and I'm going to say, okay, I have 0.36. Actually, I'm going to change the color here because this is now comparing. Okay, and it's important to know that what we are working at now is just to check which is in excess. We're not going to necessarily use this information for anything else. Okay. So I'm going to use 1-to-1 ratio, and I'm going to say needs. So this many moles of iron needs 1-to-1, 0.36 moles of sulfur. Remember, I'll always write it underneath so that you have a way to see it. Okay, visualize it. Now you compare. Just use a pencil now. So we're going to compare. We have 0.44. That's how much we put in a container. We put 20 grams, we put 14 grams. We see here we have excess. Now look at this. See, this one was 20 grams and this is 14, and we're actually in excess of sulfur. You would think it was the iron, but it's not. It's the sulfur. So we have too much sulfur because all we need is that. 0.36 moles of iron needs 0.36. We have too much sulfur. So what do we know? Sulfur is excess. Iron is limiting. Okay, let's take a look at B. It says determine the mass of the substance in excess left over at the end of the reaction. Okay, so let's take a look at, so this is B. Okay, B. So I'm going to do B here. So we know we have 0.44 moles of sulfur. Now I'm using sulfur because they've asked for the excess, and so sulfur is in excess. Okay, I've used 0.36 moles of sulfur. How do we know this? Because all of that, because remember the limiting always depletes. There's nothing left of the iron, and so there would be it would react with the same amount, because it's 1-to-1 here. It would react with 0.36 moles of sulfur, leaving us with, now we're going to subtract. Okay, so 0.44 minus 0.36. I should be able to do this on my own, but I don't want to. 0.08 moles in excess. Okay, but they asked for how much mass was in excess. You've got your moles. Okay, you're going to just use your formula. So we have 0.08. Mass is in excess. We have sulfur, which is 32. We times the two together, and our mass is equal to times 32. Oh, I think I've done it wrong. 0.08 times 32. 2,56 grams. 2,56 grams left over. Okay, please watch it over and over and over. All right, the next one is, I've written the formula down already. Okay, so let's go with this. In experiment, 20 grams of magnesium, 20 grams, and 9,6 grams of oxygen, 9,6 grams. Sometimes it could be obvious, but sometimes it's better to just be careful. Reacted together. Calculate which of the substances is in excess. Strange. Normally we do ask for the limiting. Okay, so we're going to do number of moles for both. When in doubt, mole it out, but we're going to do it for both. Okay, so number of moles is equal to 20 over magnesium is 24,3 according to our SAGS document periodic table. Girls, please remember you leave that 2 alone. I'm saying it again. When you work out your molar mass, you do not include that 2. Okay? That only is used for ratios. That is it. Okay. So 20 divided by 24.3. And we get 0,82 moles. Okay, now let's go with this one because we can't compare moles with grams, so we need to compare moles with moles. So this is the same thing. Moles is 9,6 divided by oxygen. Now we include that too because it is part of the molecule. Okay, so this is 32 because it's 16 for oxygen, but times by 2 is 32. So 9.6, no, yes, I'm right. Sorry. Okay, 9.6 divided by 32 is equal to 0,3 moles. Okay, I did already balance this, but please guys check that it's balanced before you do anything. Okay, so now I'm going to take this one. I'm just going to take the first one. You can do that one with that one, but it's just pick one. Okay, and I'm going to say, okay, 0,82 moles needs how much? We know that it is a 2:1 ratio. 2:1 ratio. Okay, it needs, divide by 2 times by 1. So 0,82, and it's probably going to be 0,41, but anyway, it's late and I'm tired. Okay, 0,41. Now I've done it in another color because this is just my comparison. This is not how much I have. I need 0,41 in order to react with all of that. I need that much oxygen. So we're going to compare now. We compare. We have 0,3. We only have 0,3. I needed 0,41 to react with all of the magnesium, but we don't have enough. So not enough. So that means this is the limiting reagent. Therefore, O2 limiting and magnesium in excess. Okay, I've really tried to think of step by step here. Okay, so please try and follow the steps as I've given it to you. They must be, it should be logical. Okay, if you're finding it a little hectic, try and watch the videos again, but and see how you go. If you really are struggling, I will do some more for you. Okay, so let's take a look. Number B. It says determine the mass of the substance left over at the end of the reaction. Obviously, because these are not all the questions you can ask. Normally, sometimes they just ask you for the limiting reagent. And then you've got to remember to use that limiting reagent only when you're determining something. So if, for example, I said to you now, what mass of magnesium oxide was made, you would ignore the 9,6 here. Oh, sorry. This one's in excess. You would ignore the magnesium and use only the oxygen's 9,6. You wouldn't worry about that This is in excess and there will be left over. So you don't look at that. This lets you know how much of that is actually going to be produced with this much left over, with that left over. Okay. So when you've discovered which one is your limiting, you ignore the excess one to work anything else out. Okay. So let's take a look. Now we need how much is left over though of the magnesium. Now we're going to use the magnesium. Okay. So we know we have 0.82 moles of magnesium. That's what we have. Okay. What do we need, or what is used? Okay, now we do have to do a little bit here because we compared this one and became the limiting. So I need to know backwards now. Well, how much am I going to use of the 0.28? And so we can see there, if we're going backwards, we divide by the first times by the second. So we're going to need 0.6 would be used up. Okay, because remember, this is the one that's reacting completely now. And because it's a 1:2 ratio, and this one is in excess, I need to see now, well, if this one's going to react completely, how much of this is going to be reacted? And it's a 1:2 ratio, so we times that by 2, so we're going to use 0.6 moles of magnesium. Okay, we subtract. So that's going to give us 0.22. Hope I'm right. Am I right? Should be right. Okay. In excess. Those are moles. So we're going to say mass over molar mass. 0.22 is equal to mass over, this is magnesium. Magnesium was 24.3 times the 2 together, and we get 0.22 times 24.3. Okay, 5.35 grams is left over of the 20 grams of magnesium. Okay. All right, so I hope that makes sense. Please watch it over and over and over if you're getting stuck. I would like you to start these think tanks. You can continue with them on Monday. Okay, so Monday is our triple, and it's the last time I'm going to see you before your study leave because I don't see you on Tuesdays. So I'm going to, and the problem on Monday, we have a problem, is that I actually have a meeting during your period with the IEB, Mrs. Swan and I. So I'm going to give you some more examples. I'm going to give you some from the papers that I've uploaded already for you. And you're going to finish these and you're going to tell me if you're needing more support with it. Okay, I'll be here for you on the Wednesday, Thursday, and Friday during our time if you do need to ask questions. Okay, but I will tell you this again. All right, girls. Hope you have a good weekend.